for a year. So the effect of the aftermath of everything that happens is happening, and still gonna see the results. So the harsh weather of the UAE, when it comes to UV, humidity, high temperatures, and water, cause a lot of damage to the infrastructure, and the materials that we're using actually are not resistant, or maybe after a while are not as efficient, which leads to a higher temperature in the houses, deterioration of the material, cement cracking, fungal growth, and high energy bills. So what we were looking for is a material that can answer to all of these questions, and at the same time maybe replace some of the current materials that we're using, like the concrete, the paints and the coats that are being used that cannot really handle the high, the harsh climate. So Airgraph is actually a proprietary graphene nanopolymer. So it's actually a mix between, or a hybrid between fiberglass and carbon fiber. We managed to develop it here locally over 3 years of research and development and application in Al Ain, Abu Dhabi, and Dubai, specifically in the desert region, where we built greenhouses and living environments where they can withstand and test the very harsh climate. So what is it? So Airgraph is a self-assembling graphene nanopolymer, usually to functionalize graphene and use it in different polymers or matrices. It takes a lot of energy, around 1,000 degrees, or you need to use plasma to activate the carbon. What we did is we found a way to activate and functionalize the graphene using other nanopolymers that interact with each other. When we mix our matrix, actually what happens is an exothermic reaction happens, and the carbon gets distributed everywhere in the matrix that we have, and we get rapid and scalable production, so we can produce building material and coats and paints that can be used in construction. So if you see this, all these panels are from our boards that we created. So this is a sample of how it looks like. It's very light and strong at the same time. It can resist most of the material elements that are available in the UAE and the GCC. So these are some of the characteristics. So it has very low density, high strength, corrosion resistance, UV resistance, it's antimicrobial, it's antibacterial, it even has magnetic shielding, so it can be used for military application or for server protection from attacks. I'm going to show you guys a few of the applications that we are thinking of since we've tested construction. So we can do floating homes, we can do 3D monolithic construction, extreme climate resistant paints and coatings, and floating homes. In terms of marine application, the material is completely hydrophobic, and it does not decay, and it does not grow any barnacles, so it can be perfect for marine application, hulls, platforms. In terms of defense and aviation, so we can make light drones resistant to the heat. We can cool it internally using liquid nitrogen, since the material can handle plus 450 degrees and minus 200 below zero. So it has a lot of applications and a very long, wide range. It can be used in automotive, EV vehicles, housing compartments for the batteries. We can use it to make the solar propellers, for the wind propellers for energy generation, wearable technology, and a lot of other applications. This is obviously a huge industry. Nanopolymers and advanced materials is a $513 billion industry by 2023, and by 2030 it's estimated to be around $1.2 trillion. So thank you very much.